Hello there. All right, we are on video 11. This is the last video of chapter 7. This is chapter 7, section 5. And this is about solving trig equations. And I don't know if I've taken you to the textbook yet, but I want to do that because there's some information there that I thought, oh, this is really good, and I should write this down for them. And then I thought, they can read it. You guys are smart kids. You can read it. So here's how you're going to get there. And this is good for you to know because I'm referencing this book, or I'm using this book for both varsity and your notes. So you can utilize it. You can highlight in it online. But you can also download it as a PDF. You can take some electronic notes in it, that kind of thing. So I'm going to go to varsity, and varsity's here. And in varsity, if you scroll down, let me see, make sure I'm looking at it as an instructor. I'm going to switch over to student view and just make sure you guys see the same thing I'm seeing. You do. So right here, this OpenStack PreCalc book. If you click on that, what it's going to look like, and it'll take a minute, so I did that prior to actually bringing you here, but it will look like this. It'll open up in a separate tab at the top, and it's sitting right here, and I'm going to take you to that. It will look like this. So table of contents over on the left-hand side, I'm going to click the table of contents. Notice there's a download an app, I guess, view online. I downloaded the PDF, and you can save it right into your computer, which is handy. That also, the first time, opened up with a table of contents that I could navigate around in. I couldn't find that the second time, but there's a couple of things that you can utilize here in terms of the get a book. Now, here we're in chapter 7, section 5. So I'm going to navigate to that in my table of contents. So here, trig functions, we just finished chapter 5. We skipped chapter 6 because that's all graphing. And here's chapter 7 for you. And we're in chapter 7, section 5, solving trig equations. So I'm going to click on that. And it's going to take us to that part of the book. And there's page numbers in there. There's all sorts of good stuff. I'm going to actually close the table of contents over on this side because it just gives me more space on the page. There's some learning objectives at the top, which is fantastic. It gives you some information there. And then there's some good reading, some examples. It shows you solutions here. Find all possible exact solutions for cosine is a half. And then it shows you how they work that out and gives you some good information. Now, I'm going to teach you what is happening here. What I want you to do, and I'm going to go and state this. You'll see page numbers again. I'm going to go to the top of the page. Oh, there's no page number on this page. Let's go to the bottom of this page. Maybe that's where my page number is. Why are there no page numbers? Oh, this is poopy. When I did this, maybe it's because I closed my table of contents? I don't know. I'm going to open that back up again. This is very strange. I hate when this happens because then I feel unprepared. I literally wrote, read the bottom of page 603. And now I don't even see. All right, well, here is 603. So this is the statement. Read the bottom of page 603 in the textbook under the subtitle, Solving Linear Trigonometric Equations in Sine and Cosine. So that is, this is interesting. This is a pen. I'm going to just write on here. So I want you to read this paragraph under here. So this piece of information, okay? And then here is what I want you to do with that piece of information after you've read it. And I'm going to write this back in the other screen. I want you to, in 30 words or less, write a summary of those two paragraphs and put that summary first in your notes. Okay? So you're going to go to the text, go to chapter 7, section 5. And this is right at the beginning of this section. I need to close this. So I'm going to scroll back up to the top. This is the top of chapter 7, section 5. And it's not, ooh, there's that pen again. I don't know how to make that go away once it's gone. So you're going to scroll down just a little bit to those 2 paragraphs. Read those 2 paragraphs. I'm going to click back here. And the first thing in your notes is you are going to write a summary, the 2 paragraphs from the text in 30 words or less, using good grammar, paragraph form, English. Do not write to me like you're texting. Don't use abbreviations. Don't use things like LOL, IDK, that kind of stuff. Write to me like I'm an English teacher. Okay? Capitalize your sentences, use punctuation, all that good fun stuff. 2 paragraphs from the text in 30 words or less. Use good grammar, punctuation, capitalization, etc. When you're done, I want you to do a word count and box your word count. So you might have 28, put it in a box. Okay, so summarize the 2 paragraphs from the text in 30 words or less. Use good grammar, punctuation, capitalization, etc. Do a word count, box your word count, and then continue your notes. Okay, you should also know, though, that textbook is there. There are practice problems in there. I do not know. I haven't looked enough to know if there's an answer key. I do know that they work some of them out. There's some samples that they show all of the work and that there are answers in there, that kind of thing. So that could be an alternate form of information for you. Okay? All right, so here is what we are going to say. And you do need to have your unit circle because that's going to be important. A couple things of review also. Remember in the unit circle that all students take calculus, which meant that all your trig functions were positive here. Sine was positive here. Tangent was positive here. Cosine was positive here. And they're reciprocal functions, right? So there were places where like sine is positive in 1 and 2. Tangent's positive in 1 and 3. Cosine's positive in 1 and 4. What we're going to be doing here is we are solving trig functions, trig equations. Okay, but if you're not told that this is happening in one rotation, meaning between 0 and 360 degrees, then if you find out that something happens at 30, it's also going to happen at 360 plus 30, 720 plus 30. So it's going to continue to happen at every single rotation. And so we're going to need to allocate for that based on what you're being told. Okay, so let's just kind of get right into it here. All right, example 1. Cosine of theta is a half. You're being told that. And you're not being told that there's any kind of constraints. And what I mean by that is sometimes you're told that theta is between, that's a 0. 0 is less than or equal to theta is less than 360 degrees. So now you know that you're only talking about one rotation, okay? If this is not in there, then you're talking about every rotation. And here is where that comes into play. Well, we know from the unit circle, cosine of theta is a half. This is true at 60 degrees and at 300 degrees, right? You can go back and check your unit circle. That is a true statement. That is true at those two places. Well, that means that it is also going to be true at 60 plus a full rotation, plus 2 full rotations, plus 3 full rotations, plus 4 full rotations. So what you're going to do is you're going to add to that a rotation and a K, where K is, it starts at 1, is an integer that starts at 1 and increases. So basically what happens is if K is 0, actually it starts at 0. So if K is 0, let me get more space here, then it's just 60, right? So if this is the 360 times 0 would be nothing, and you'd have 60 plus nothing. So it's just 60 degrees. If K equals 1, then you have 60 plus 360 degrees, which is what, 420. And that would be, here's your 60 degree angle. You'd go around one time and then come back to 300 to 60 degrees. Okay. If K is 2, then you have 60 plus 720. So you have 2 rotations. So you'd go around another time and you'd land at the same angle. If K is 3, oops, that's an F. Then you have 60 plus 720 plus another 360. So you'd go around another time. And basically what happens is you just keep adding rotations as K just keeps on getting bigger and bigger and bigger. So this allows for every possible rotation ever, forever, until infinity. Okay. And then we're going to do the same thing for 300, because here's your 300 degree angle down here. And so if K is 0, that's where we end the first time. And then if K is 1, it adds a rotation. Then if K is 2, it adds another rotation. And if K is 3, it adds another rotation. And blah, 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 blah. So you just have plus 360K. So these would be the two answers, and the way that they would need to be put on your paper in order to make sure that that would happen. Okay, now, if this is in degrees, this is also in degrees. If this was in radians, meaning pi over 3, then you would add 2 pi k, because 360 is 2 pi, right? So if your angle's in radians, then your multiple rotations is also in radians, okay? So if your answer's in degrees, your multiple rotations can be in degrees. If your answer's in radians, then your multiple rotations also have to be in radians. So it depends on what you're talking about. So this is a very, very basic example just to introduce to you what can happen. Okay, if you're being asked to say cosine of theta is a half, well, where does that happen? You know it happens at 60 and at 300. But then it happens forever and ever and ever as you continue to make these bullseyes around this circle. So it's going to happen every time you go around the circle. Okay. With sine and cosine, you're going to have two answers like this, where you're going to add 360 degrees to each of them. Tangent is a little bit different, and we'll talk about that when we get to that. But we'll do that in a little bit. Okay, I want you to do some sines and cosines first. Oh, next page, not further down the page. All right, here's another one. Solve 2 cosine theta Now this one you actually do have to solve. Minus 3 equals negative 5. So what we want to do here, solve it like a regular equation. So if this was 2x minus 3 equals 5, you're essentially, good Lord, that's the worst x ever. You're essentially doing exactly the same thing. So we're going to add a 3 and add a 3. 2 cosine theta equals negative 2, right? And then you want to isolate the cosine, so you would divide that by 2, divide by 2. And so cosine theta equals negative 1. Once you solve it, the question you need to ask yourself is, where does this happen? And this is really the all-important part of this section. It's not the solving part. It's finding out where it actually happens. So you can take a look at, actually, let me, excuse me, let me pull in a unit circle. It's going to take a little second here. My content, pictures, let me pull in a unit circle. Okay, we'll push that, oh geez, push that down the page a little bit. Eraser, I need an arrow. Okay, so we want to know, where is cosine negative 1? Well, recall again that when we're talking about these, the ordered pairs are always cosine sine. So we want to know, where is the x coordinate negative 1, right? And that happens at a quadrant angle. So let's look down here. And we're looking at our quadrant angles. Where is our x coordinate negative 1? Well, that happens right there and only there. It is the only place that that happens. Okay, so cosine is negative 1 at 180 degrees. I'm going to push that down the page a little bit. Oh, arrow. Push that down the page a little bit just to make some room. So we now know that cosine is negative 1. This happens at 180 degrees, and it's going to happen every time around the circle. You should see me in the air. I'm drawing like rotations. So this is going to happen plus 360K. And that would be your answer to that question. Okay? All right. Now, the next one, I think all the rest of them are going to have some constraints on them. So you won't have to deal with this 360K thing. So we're going to be talking about just one rotation of the unit circle. All right. So the next one is solve 2 sine squared theta minus 1 equals 0. All right. Well, we want to get the sine squared by itself, so I'm going to move the 1 to the other side and change the sign. Equals 1. Then I'm going to divide by 2. And remember, this is attached to the sign by multiplication, right? So I have to undo the multiplication by division. So I have sine squared theta equals a half. Now I'm going to undo the squared by taking the root. It's the only way I can do that. And remember, when you take a square root, this is kind of a biggie. Be sure to put a plus or minus in front of the radical. Right? And the reason for that is just for simplicity's sake. This is both 3 times 3 and negative 3 times negative 3. So if you take the root of 9, technically this is both plus and minus 3. You don't know which one it is. So you need to make sure you're putting both of those there. So going back to my answer over here, this is going to have a plus or minus in front of it. Okay. So now I have the sine of theta is plus or minus, the root of 1 is 1 over radical 2. Well, now I've got to rationalize that thing. rad 2 over rad 2. So now I have the sine of theta. That's supposed to be an equal sign. Equals. I also forgot something in the instructions. I'm sorry. I'll go put that in a second. Equals plus or minus rad 2 over 2. And here's what I forgot. At the very beginning, I'll put it in black. This has a semicolon after it, and it says 0, 0, not theta, is less than or equal to theta is less than 2 pi. So what this means is that we are working in one rotation. So 0 is less than or equal to theta is less than 360 degrees. This means one rotation. Okay, so we're only going from 0 to 360 degrees. You're not going any further than that. Also, you're including 0, but 2 pi, it's less than 2 pi. So if you end up having something on the axis here, it can be 0, but it cannot be 2 pi because it's less than 2 pi. So pay very close attention to these. These are called constraints, restraints, whatever you want to do. I usually call them constraints on the problem, okay? So now, here's another question you're going to ask yourself. We solved this. Well, where is sine rad 2 over 2? That happens at 45 degrees. Now, this question, because this is given to you in radians, you're going to answer in radians. So 45 degrees is pi over 4. And because we have a plus or minus, that means all 4 quadrants that this is true in. So again, let me toss a unit circle in here. Unit circle. I'm going to grab this and pull this down the screen a little bit. All right, so if I take a look at my unit circle here, sine, right, I'm looking for where is sine rad 2 over 2. Well, I know that happens at pi over 4. It happens at 3 pi over 4. And it's plus or minus rad 2 over 2. So 5 pi over 4 and 7 pi over 4. Because all of the signs, plus or minus, it doesn't matter if they're positive or negative. So this is going to happen at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay? So the answer to this question, I'll do this in blue. Theta is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And you should list them from greatest to least if you're listing them for all one angle. Okay. If I only had positive pi over 4 or positive rad 2 over 2, it would have been just these two. If it had been just negative, so these are positive, these two are negative, right? But because it was both plus or minus, I needed all 4 of them. Okay. So you have to be very careful when you answer these questions because one little sign error can toss off some answers for you. All right. But this comes down to how well, A, you can do your math, and then B, how well you know your unit circle. Okay. Let's do another one. Okay. Find all exact solutions. And by now I would think you would know that exact solutions means we're talking about radical values. You're not looking for decimal values. Find all radical solutions of 2 tangent x plus 3 equals 5 plus tangent x, where 0 is less than x is less than, not less than or equal to, just less than. I need an undo button. We're not undoing. Oh, good Lord. I hate when it does that. Tangent x, where 0 is less than or equal to x is less than 2 pi. All right, so we're going to go ahead and solve the information here on the left-hand side. So the first thing I'm going to do is distribute the 2, get my tangents on the same side. So I have a 2 tangent x plus 6 equals 5 plus tangent x. Now I'm going to subtract off this tangent. And I'm going to subtract off a 6 all at the same time. So these are going to go, these are going to go. And that's going to give me a 1 tangent x equals a -1. All right, well, you're solved, right? This is now solved. And we are looking for where this happens in one rotation. Now, if you really know your unit circle, you know that tangent equals 1 at 45 degrees. And tangent is negative in these two quadrants. 45 is a reference angle, which means we're looking for 135 degrees and 315 degrees. Those are the two angles that would be in quadrants 2 and 4 because that's where tangent's negative. And then I need these in terms of radians, right? Well, 45 degrees, and this is just how I think, but then I'll show you how you can make this simpler for yourself. That's pi over 4 is right here. This is pi over 4. Okay, so pi over 4, 2 pi over 4, this guy's 3 pi over 4. 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So these are the two answers that you're going to have for this question, okay? I'm going to just flip back to my unit circle, though. Now, tangent is -1, right? That's what we know. I'm going to go back to my last screen and go to my unit circle at the bottom. Okay, I'm also going to erase these circles on here. Now, you guys don't have tangent on here because there's sines and cosines in these unit circles, right? It might be worth your time. And really, you only need to do one of these quadrants because all the signs, S-I-G-N-S, are different, but the values are the same, right? So remember that you can find tangent. Let me get a pen. I'll get something different. And I'm going to give myself a little bit more space here. Let's talk about these guys. Remember that tangent is sine over cosine, right? So if I want the tangent of 240, I can take the sine of 240 over the cosine of 240. And I know the sine of 240 is rad 3 over 2. It's negative. And the cosine of 240 is -1/2. And I can now go keep it, change it from division to multiply, and flip it. And this is gone. And then I simplify. Well, those are gone. Negative and a negative is a positive. And this is just radical 3. So the tangent of this is radical 3. So what does that mean? That means that every 60-degree angle or anything that has a 3 in the denominator is going to have a radical 3 for a tangent, but the SIGN will be determined by the quadrant, right? So tangent's positive in 1, it's negative in 2, it's positive in 3, it's negative in 4. So I'll do that one for you. You guys could take these and figure out the tangent of 210. You could figure out the tangent of 225. And then you could also figure out the tangent of all of your quadrant angles. Some of these will be 0 and some will be undefined, the quadrant angles. These ones over here will actually have values to them. Okay, but you could find your tangents for all of these so you don't have to figure them out all the time, and you can't do them in a calculator because you'll get a decimal value. So it might be worth 10 minutes of your time, maybe 15, to go through and figure out these two. And again, I'm literally saying two because once you know those two, you can fill in all these arms on here. And then the other ones you would have to fill out. You'd have to do these ones separately, right? And remember that if you have, just remember, if you have some value over 0, this is undefined. So that's going to happen for a couple of those. And if you have 0 over something, this equals 0, right? So that's a couple of them. 2 of them are undefined and 2 of them are 0 for the quadrant angles, the blue ones, right? So I would take a couple of minutes and actually invest the time and do that. So I'm kind of color coding here so you know what's happening, all right? Take the time to do that. Write your unit circles out, put your tangent values on there. You have the sines and cosines already. Might as well do the tangents. Once you know your tangents, then you also know all of your secants, cotangents, because all you have to do is flip them all, right? So, worth the time. I would go do it. I did it when I was in pre-calc and calc. You should probably go do that too. All right, especially since you can use stuff like that on your tests. So, there you have that. All right, next question. Okay. I referenced your book here again. I wrote, see the book, and I put a page number. I don't know if you have page numbers in there. See the book, page 607. Do I have a pen? No, I don't think I do. Page 607. For an example, using the quadratic formula. To solve a trig equation. Now, quadratic formula in general is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So here's what we're going to do. This is example 10 in the book in this section. If you want to have that open on another tab. And it is to solve cosine squared theta plus 3 cosine minus 1 equals 0. And then there is a constraint on it, and I'm going to put it up here because I just don't have the space. 0 is less than or equal to theta is less than 2 pi. All right, so I would first look and see if you can factor this. If you can't, and you can't in this one, then we're actually going to look to do this whole quadratic formula. So remember that these are in the form, and actually what we're going to do, I'm going to actually transition this thing to make it just look like this. This would literally look like x squared plus 3x minus 1 equals 0. And we're going to plug this into the quadratic formula, looking just like that. So we're basically substituting, we're letting x equal cosine here. Okay, so remember that these are in the form ax squared plus bx plus c. Okay, so our a is 1, our b is 3, our c is negative 1. So if we solve this, negative b would be negative 3 plus or minus the root. B squared is 3 squared, which is 9, minus 4 times a is 1, c is negative 1, all over 2 times a, which is just 2. Next step, negative 3 plus or minus the root. Here's what I like to do mine like this, 9, and then these all get multiplied together, and that's just going to be plus a 4. So this is going to be a 13 in here, all over 2. Okay, so we now have x equals negative 3 plus or minus red 13 over 2, but remember that x equals cosine theta, so really cosine theta equals negative 3 plus or minus red 13 over 2, just by straight substitution. That's all that happened there. And then in a calculator, if you don't know the value of the angle, and that's what we're trying to do here, and this is kind of a wacky problem. It's a little bit outside the box. But there is a note in your textbook, and I will put it here. Note. We can only use the positive value because the negative one will give you an error. When you try to solve this in a calculator. Okay, so what we're going to do is, because we don't know the value of the angle, so we're going to go inverse cosine, and we're going to use the plus rad 13 over 2, and you're going to get theta. Okay, and in this problem, it's approximately 72.4 degrees. All right, and we know we're looking for cosine. Cosine is positive here and here. So this gives us the 72.4 degrees in quadrant 1. We also need the quadrant 4. So you're going to go 360 minus 72.4 degrees. And you're going to get approximately 287.6. And this is specifically a varsity question, and I need you to know how to handle that guy. So that's what's happening there. If you had sine, you would then have to take, instead of 360 minus 72, you would take 180 minus 72. If you had tangent, you would have to take 180 plus whatever. Because remember, when you're doing these, if you have whatever these quadrants are in, you have your reference angle. This is your acute first quadrant angle. And then to find the others, you do the following. In quadrant 2, you do 180 minus your reference angle. In quadrant 3, you do 180 plus your reference angle. In quadrant 4, you do 360 minus your reference angle. Okay, so that's how you find your other angles if you had forgotten that from early on in, I don't know, chapter 5, I think. So, all right, that's how you do that. Now, a couple more quick little examples on solving. I think there's 3 more. All righty, here we go. Let's get these out, bang these out, and get these done. So we're going to go solve 2 sine squared theta minus 5 sine theta plus 3 equals 0. And you're given a constraint of 0 is less than or equal to theta is less than 2 pi. All right, so here you have a trinomial. And you could look at it like this: 2x squared minus 5x plus 3 equals 0, which, gosh, I hope we went through and solved and reviewed. If we didn't, I have a review that I can throw in here with it, but I use what's called X method, where you multiply a times c, that's a and c, and that's 6. B goes down in the bottom, that's the middle term, and then you're finding 2 values that multiply to the top and add to the bottom. So -2 times -3. Then the next step is to divide by a and reduce if possible. And then if we were doing a quadratic like this one. Now remember, kind of all I did here was replace let x equal sign. That's all I did. So if I was solving this guy in red, 2x squared minus 5x plus 3, with the blue boxes, the bottom number comes up and gets a variable, and the top number just stays as is. So this would be the 1 would come up and get a variable, so 1x minus 1 and 2x minus 3. And that would be the factored form of that quadratic, but I let x equal sine. So I'm going to just now say sine of theta minus 1 and 2 sine theta minus 3 equals 0. And then remember, whenever you factor and solve, you set each factor equal to 0. So now I'm going to take this factor and set it equal to 0. And set this factor equal to 0. And solve each of them separately. So I'm going to move the 1 over here. So sine theta equals 1. And then move the 3 and divide by 2. And if you need to do this in 2 steps, that's fine. But if you can do all of that in your head, and then just end up with 3 over 2. All right, so this is interesting, and I don't know if you've actually graphed this. So I'm going to go do this in Desmos for you. This will take just a little second, but we're going to go to Desmos. We haven't really talked about constraints on the sine and cosine function, but you should be aware of this. Let's go to graph. And I'm just going to graph the sine function for you. And cosine has the same constraint. So you'll want to see what this is. So we're going to just type in here. Where's my keyboard? I got to get rid of that. Get the keyboard. You want to type in sine of x. And you parentheses. Where's their keyboard? Where are my numbers in here? I need their keyboard. Keyboard? Oh, here we go. This is better. Get rid of that. So sine of x and close it. Hang on one second. I'm going to attach a keyboard so this stops popping up all the time. Give me 1 second here. We're going to delete this. Go. Yeah, okay, there we go. All right, so if you take a look at the sine function here, can I zoom in here? Oh, that's a little too far. Notice that the highest, it's this just continuing curve. The highest it ever goes is 1, and the lowest it ever goes is -1, ever. If I scroll out, zoom out, it just keeps happening over and over and over again, and it never goes higher or lower than 1. Cosine is the same way. So going back to what we have over here, sine of theta is 3 over 2. Well, 3 over 2 is 1 and 1/2. Oh, that's probably going to make a terrible noise. I'm sorry. And so because that is 1 and 1/2, that is something that can't ever happen as a sine value because it's bigger or smaller than 1. So this is what is called an extraneous solution. And that's all you really need to write to me. You should cross it out if you were doing this on paper. You should write that it's an extraneous solution. It does not exist because, and this is for your notes and for you, you wouldn't have to write this on a test or anything, because -1 is less than or equal to the sine of x is less than or equal to 1, right? It never goes above or below -1. So also this is true of cosine. Not true of tangent, strangely, but it is true of sine and cosine. So this value is not going to exist. Well, this one, where is sine actually 1? That is a quadrant angle. You can consult your unit circle if you want to do that. But this is actually, that happens at pi over 2. And that is the only place that that actually happens. Okay, so here's an example of solving a trinomial trig function by factoring. Okay, you can group these things. You can solve with, I hate to say this, but difference in sum of cubes. There's all sorts of different ways to do that. The next one we're going to solve with factor out a greatest common factor. So here we go. All right, this one solve 2 sine squared theta plus sine theta equals 0, where 0 is less than or equal to theta is less than 2 pi. And so what you're going to do here is factor out a GCF. And that GCF is a sine of theta. Excuse me. So I'm going to take out a sine theta, and that's going to leave me from the first term, it will leave me a 2 and a sine theta, right? Because there's 2 of them there. And from the second one, it will leave me just a 1 equals 0. And then I'm going to set each factor equal to 0. So this guy, and then this guy, and this actually is ready to be solved. Sine of theta is 0 at 0 and pi. So again, use your unit circle. And theta equals 0 and pi. And then this guy I'm going to solve. So I'm going to move the 1 and be negative 1, and I'm going to divide by 2. And so sine of theta is going to be a negative a half. And off top of my head, I know that sine of theta is a half at 30. But now I'm talking about quadrants 3 and 4. So that would be 7 pi over 6 and 11 pi over 6. So theta is 7 pi over 6 and 11 pi over 6. Okay? And that's how you're going to do those guys. Let's see. What's the next one? The next one throws a couple of curveballs in your direction, so we want to make sure that you know how to handle that. And this is the last one. So this says solve 3 cosecant theta plus 6 equals 0. And it does not give any constraints. So this is just a note from me. There's no constraints here, which means we're dealing with all possible rotations. Okay. And let's go ahead and solve. So we're going to move the 6, make it a negative 6. And then divide by 3. So cosecant theta is negative 2. Well, personally, I don't know a whole lot about where cosecant is negative 2, but here's what I do know. I know that that would mean sine would be negative a half, right? And I know a lot about where that happens. In fact, it just happened at the last problem. And this happened where theta was 7 pi over 6 and 11 pi over 6. So sometimes you need to do this, right? We don't know a whole lot about where this actually happens, but we know a lot about where its reciprocal function happens. And then because of the no constraints here, this is going to also happen at plus 2 pi k and plus 2 pi k. Okay, so those are the 2 answers to those guys. All right, and this is 7.5, and that wraps up this whole chapter, I think. Good job. So we are moving into more normal trig after this section. Good work, kids. Toodaloo.